This is the 8th in a series of modules about productive tutoring techniques. You, the viewer, will have an opportunity to see actual tutors handling real tutoring situations. These scenes will benefit you the most if you take time to think about and discuss what you see. Throughout this module, this screen will appear as a prompt for reflection and discussion. Tutors employ direct techniques when students need help in organizing and understanding subject matter. The extent that direct techniques are used in tutoring sessions will vary with the characteristics of the student, the course instructor, and the subject matter. Tutors will use more direct techniques in high-structure sessions than in low-structure ones. Tutors should be cautioned that the overuse of direct techniques can place students in a passive role that will reduce their attention and active participation in the session. Used correctly, however, direct techniques can help keep the student focused and the session interactive. Tutors always should allow the student to direct the tutoring session as much as possible. However, some students will require highly structured tutoring sessions and will need more suggestions from the tutor, at least in the beginning of the tutoring relationship. At times, even highly motivated students in low-structure sessions will need more direction from the tutor. Let's see some examples of how the tutor suggests a certain course of action in a tutoring session.
All right, so what would you like to do with it?
Well, just pretty much go over it so we can understand it. Well, so you can put your little in it and tell me what's wrong with it. If you see anything wrong. Yeah.
If I see anything wrong, in what way?
Well, in maybe grammar or punctuation stuff.
All right, well, let's go through. You read it.
Okay.
And did you already check for punctuation?
I'll try my best.
Let's do this problem.
Which number?
17. I'll let you write.
All right.
Just do the first reaction.
They did earlier, but it would not be they. It would be one of them did earlier. Okay, is that
Okay, but that doesn't change the meaning either. Both of those changes are just rewording without changing the meaning. Why don't you just put a mark by that and let's keep going.
All right.
A good tutor helps students locate their errors and makes suggestions to help them avoid future errors.
So
that's your POH. Now
that's
find
my
PH.
I know that PH
Well, okay.
subtract.
Make sure it's the negative log, so make sure that's the part. Okay.
Thank
All
you.
right.
It's not the coworker part that's the problem. The part that I don't understand is that you sound as if you're saying that Tanaka and Sengo somewhat based their study on one done earlier by Tanaka and Farah, and which makes it sound as if they're two different groups of people.
Okay.
Now, let's go back a step. You had 2 times negative 9.8 times 30. What did that give you?
588.
Negative 588.
Mm-hmm.
Right. Equals negative VI squared.
Oh, okay.
Okay.
I'm
so
trying to
that's
skip,
where the
okay.
negative went.
So it's still positive. I just
Right.
I messed up on my signs. Okay.
Right. You just
Because
I wanted to
bring
make
it
sure you
over.
understood that negative doesn't just disappear because you can't take the square root of a negative number. That's why the calculator wouldn't let you.
Yeah. See, I just made it disappear.
Okay, you have a grammar problem there. Can you find it?
In which it would be comma. All right.
Why?
Because it's like 2 complete sentences and it's a runoff.
Okay.
So I'm putting-
Tutors should use direct explanations only when they are unable to get the student to discover the concept. Explanations should be made slowly enough to allow the student to think through the ideas and ask for clarifications.
Amines are Lewis bases, and carboxylic acids are, by definition, acids. So, because of this here, see how this is accepting. Well, this is a carboxylic acid. You see how this is accepting the electrons from that oxygen? So that makes it an acid there. It could also function as a base by losing those electrons like we've been talking about.
So is it either?
So it's either, right?
Carboxylic acids are always either, or is it either because it's also an amine?
It's either because it's also an amine. Carboxylic acids are
Always
acids.
acids.
Yeah.
And only acids. So it didn't have that. It'd be carboxylic acid,
Right,
and it would be just an acid.
right.
Can't you take the log of 23?
Yeah.
Okay, so log of 23 is 1.4. So 1.4 is equal to what?
Log of 5x.
Right.
Oh. Alright.
Pero is like but, right? And sino is but too. But sino is like if you have, like in English, if you have a negative part of a sentence, but you want to say, on the contrary, I'd like to do this. Like, if I wanted to say, I don't want to talk to you, but I want to talk to Pablo, I'd be like, no quiero hablar contigo, sino con Pablo. I don't want to talk to you, but I'll talk to Pablo. You know?
All right, so it's like it has two parts to it.
Right.
I know. So like, okay, so the negative part will come first, and then the positive part will come
Right.
in the latter part. So that's when you'll know to use
Sino.
right.
Including questions has the benefit of keeping the student alert and engaged during explanations. Also, by using questions, the tutor makes sure the explanation offered is built upon concepts already understood by the student. For example, before explaining that a certain chemical reaction results in lower entropy, the tutor may ask, "What is entropy?" If the student doesn't know the answer, the proposed explanation would have been made at an inappropriate level.
And heat is just the opposite.
Okay.
What would it be? What would heat be?
Heat gives off energy.
Yeah, heat is given off as energy. So if
Okay.
you have this system, whereas in work, the system was needing energy, meaning it was endothermic,
Okay.
where now heat is going to be something that, what is the system going to be? Endo or exothermic?
Exo.
Right, so
Okay.
heat's being given off.
Given off. Okay. Okay.
But if we had this liquid, and we want to find which one has a higher vapor, what's the liquid doing? Vapor
Vaporizing
into
into like a gas.
right
Okay.
into a gas, and as
Okay.
as gas, and it's going to be in an equilibrium, meaning as many molecules of liquid transferring to gas, there's
gas going to liquid.
right.
Visuals are critical for certain concepts, from free body diagrams in physics to structures of organic compounds in chemistry to three-dimensional problems in mathematics. Also, some students learn especially well in the visual mode. For these students, visual explanations will be particularly effective.
Yeah.
And it's always important when you do, these are called half reactions. It's always important when you write the half reactions of an oxidation reaction that the electrons
Cancel out.
gained equal the electrons lost.
Okay.
So if she were to give me something like this, I would draw that. Well, this would be one product and this would be the other. And like a major and minor, there's not one, right?
Yes, there is.
There is.
What would you think would come into play if we had, say, a tert-butyl group here?
The sterics effects. So this, if it was sticking up, it would be harder to get to because this is also sticking up, so it would need to be sticking down.
Yep.
So this would be the major. This would be the minor.
Yep.
Do you know what the Z is?
No, so I don't understand that. Like he tried to draw a graph like that and said this was the z-axis, that was the y, and that was the x. But
Okay, if you have this is your y and this is your x, the z is going to be running like this. So you have a three-dimensional axis. So always before you've dealt in 2 dimensions where you have just your x and your y, and now you're going to start getting into 3 dimensions. So this is your z. So you could possibly have a point that was over here, and so it would be like -2 on your z-axis, and it'd be like over here 1 on your x-axis, and it'd be up like 2 on your y-axis. So it would have 3 different coordinates.
Okay.
So that's when you get into your z.
Real-life examples can be visualized by both student and tutor. The example becomes a familiar object, which can then be discussed in the session as an analogy to the concept in question.
First of all, do you understand what the Doppler effect is?
No, I'm getting here that there's a big picture of an ear, so it's some kind of sound
Right.
coming from.
Have you ever been you're sitting in your car and an ambulance passes by?
Yeah.
And you know how it goes?
Starts real loud and it
And
goes,
goes,
yeah.
Yeah, we don't need to example.
If the student understands the example, the tutor can refer back to those examples later in the session.
Now you can do this. What's the frequency of sound you hear coming directly from the siren?
930.
But remember how it's moving away from you? So it's like the ambulance thing. When it moves away from you, it starts getting lower in pitch.
Okay.
Okay, so you need to use that's why you have to use the general equation.
Here are some more striking examples.
But it just holds on to them tighter. And so the less electronegative isn't holding them on. So it's like a tug of war. Like if we had a rope and the rope represented the electrons, if I wanted it more, then I'd pull it away from you and you didn't really want it that bad, so you just kind of let me have it.
So I'd be the less electronegative in that case.
Like in this pen, is this disordered?
No, it's in order.
Right, because it has a definite shape,
Shape.
a
size.
definite mass. So the molecules in this pen are highly structured, highly ordered.
Okay.
Now let's say we have this gas, like this atmosphere in here.
So they're totally disordered.
Right.
Okay.
Say your electron was a big old huge ball, like this big, and my arms aren't very long. So in this case, I'd be less electronegative. It'd be really hard for me to hold that. But your arms are longer, so it'd be really easy for you to hold on to that. So you'd be the more electronegative.
Okay.
Just because it would take me a lot more effort to hold on to it, because I'd have to keep balancing it and kind of bouncing it up in the air to hang on to it, whereas you could just hold it. Right.
Okay. That makes sense.
Sometimes the tutor will need to summarize key points for the student. Such summary should be brief, concise, and to the point.
In order to do these problems, the key thing is that you need to assume that this reaction goes almost all the way to completion.
Okay.
So if the reaction goes almost all the way to completion, you should have a very large amount or a very small amount of copper.
Very small amount left.
Okay, right.
So you want to cross multiply so that y is over here with these y's and x is over here with these x's. And so then you integrate according to the y, and then you integrate according to the x. And then you'll solve for y to get an equation for y.
Yeah.
Does that make sense?
I know this isn't in the plane, but you can't draw that any other way. You just know that it's sticking up.
Yep.
So, okay. So, they're enantiomers.
Yep, and it's important to know that both of those are products and they're different molecules, because basically all that's telling you is if you start with a double bond between my hands, you can form the bond when it's turned sideways like this or when it's turned sideways like that. Either side, it doesn't matter. Just like before when we had two groups, you can flip it up like this or you can flip it down like that. So either one being up at either time won't make any difference. So therefore, you know you're going to get both products. We can't control one way or the other.
Okay.
Let's review the direct techniques we have seen. Tutors should be prepared to control the direction of the tutoring session when the student is unable or unwilling to do so. Tutors should give prompt, accurate feedback to help students locate their errors. When tutors have to explain a concept or procedure, the explanation should be made slowly enough for the student to think through the ideas and ask for clarifications. To keep students alert and engaged, good tutors often include questions in their explanations. Tutors often refer to visuals in the text and notes when explaining highly visual concepts. Similarly, real-life examples may be used to provide visual imagery and analogies to more difficult and abstract concepts. Finally, tutors sometimes need to provide brief and concise summaries of key points for the student.